G'day and welcome to another episode of Gardening Australia. Who am I kidding? I know nothing about gardening. Truth is, my wife did all of this. She installed these, what are they called again? Flowers. She put these flowers in here and I garden about as well as I dance, and trust me, you don't want to see that. So what are we doing out here in the garden? Well, the reason we are here is to have a look at this little structure that I built in our garden. Now, our neighbours decided to put up a dog fence and it was a bit ordinary looking, and we decided that we would cover that up by building a replica of a sort of a farm fence in front of that and a farm gate. Now, the gate is completely fake. Nothing works. The hinges are fake, the doorknob's fake, it doesn't open, but it does form a nice central focal point for the garden area. All of the landscape you see beyond the gate belongs to our neighbour. Now, there is a technical term for this. It's called borrowing landscape. And it does make our outlook from the side of the house look a lot better. Now, the thing is that in the morning there's a group of about 3 or 4 kookaburras that have decided that it's a perfect place to roost up on top of the gate post there. They can check out the lawn and fly down and get worms and nice things to eat, and they become a bit of a feature of the design. So I've decided that I need one more decorative element to finish off this project, and that's the subject of today's video. Now, in case you're wondering about this axe, there's a bit of history behind this. I bought this at a local second-hand market, and the dealer told me that it was Ned Kelly's original axe. Yeah, he said it's only had 2 new heads and 3 new handles, but it definitely belonged to Ned Kelly. And I mean, yeah, I believe him. I mean, why wouldn't I? No wonder it's so expensive. Now, some of you probably guessed what I'm trying to achieve here. I want to be able to make this into a pattern which will eventually get cast in aluminium, and the finished cast aluminium nameplate is going to get screwed to the top of the gate in the garden, and it's to celebrate the perching place for my feathered friends. Now, in order to turn this into a pattern for casting, we need to make this into a 3-dimensional object. At the moment, it's a flat 6mm thick MDF panel. And you're probably looking at this and saying, why did you bother laser etching the position of all of the letters on this? Well, the reason is I'm going to add individual letters in each position here to give me a 3.5mm high raised letter, and also an edge or a perimeter that goes right around the outside. And the laser etching just gives me a position so I can glue those letters down and keep the positioning consistent. Now, here's one that I did more recently. This was cast in brass, and this was to go on the side of a decorative steel bridge that I built in our garden. Here's a picture of the bridge, and here's a close-up of that same cast brass nameplate. Now, when I made this one, I used a different technique to what I'm going to do today. Now, this was made out of 3mm thick, I think it might be 4mm thick MDF as the backing, and the lettering itself is 3mm thick MDF, also laser cut, and the letters were glued down in the same way as what I'm going to do here. Now, the problem with laser cutting is that it gives you a dead square 90-degree edge on all of these raised parts. Now, that's not good for making a pattern. The problem is that in order to be able to remove the pattern from the sand mould, you have to be able to withdraw it, and it's got to pull away cleanly without breaking away any of these small areas like the center of the R and the center parts of the B. And the way I got around that was to coat this with epoxy resin. Now, the epoxy will sink down and form a fillet around the edge of all of the letters. It also tends to make a thickness at the bottom of each letter, which gives you a sort of a draft angle. It's not a consistent draft angle, but it's enough to be able to get this out of the mold without pulling away too much of the sand. But even so, I had problems. I think I did this same pattern at least 3 times until I got all of these letters to pull away cleanly without breaking away these little centre parts. Although that worked, I think this time around I'm going to try something different. And what I have in mind is to use these parts here. Now these are 3D printed parts, and I made the perimeter in 2 pieces, mainly because I couldn't fit the whole thing on my Ender 3 printer. And the letters themselves are also 3D printed, and they will get glued down in their appropriate position there. Now all of this raised section is 3.5mm thick, and on the letters themselves the draft angle that I've used there is 25 degrees. Now for most metal casting the draft angle is usually about 2.5 degrees, so why did I go to 25? Well, I want to be absolutely sure that when I pull this pattern out it doesn't give me the same problem that I had with this one here. So I wanted to be able to pull away cleanly. So what you're about to watch me do is to get this all prepped and ready, and then we'll have a go at the casting and see how it looks. But first I want to talk to you about how I modelled and printed these letters. Now these are 3D printed in PETG filament. I've only just started using this recently, but I love it because it's super strong and it sticks like crazy to the print bed and it doesn't warp. And when I created the models for these, I played around with Autodesk Inventor. That's generally what I use for my CAD work, but if you've got Fusion 360 it will work in essentially the same way. Now in Inventor, or in the Inventor environment, when you want to create an extruded letter from a type gallery, you create first of all a bitmapped image, and somehow Autodesk extracts a vector image from that bitmap, and that becomes the outline that gets extruded. As you can see here, you can extrude that vector outline vertically above the work plane or below the work plane, and you can do that indefinitely. However, as soon as you start to create any draft angle on the type, it will sometimes fail, and one of the reasons for that is if you extrude upwards vertically away from the work plane and include too much draft angle, some of the points and the geometry will start to disappear or overlap or intersect. And usually when that happens, the extrusion will fail. Now, it took me a while to work this out, but I decided that you can create the type outline on the work plane, and then instead of extruding up vertically above the work plane, you can extrude below the work plane, and then as you increase the draft angle, the footprint of the letter actually gets bigger, so that you can have extreme draft angle if that's what you want. Now, these letters have a draft angle of 25 degrees, which is way more than you probably need. But as it turns out, it allows you to extract the pattern from the mould very, very easily. And it doesn't affect the finished outcome of the plaque either, as you'll see when we finish up. I've created 2 different typefaces into folders, and I put those on Thingiverse. Now this one is called Calibri. I did another one called Tahoma, and I was able to get about 24 of the 26 letters directly without any extra work. There were a couple that were tricky, and I needed to edit the actual outline before I could get them to extrude okay. So I've done all of the letters and all of the numbers and a few special characters like commas and ampersands and that sort of thing. If you want them, you can take them off Thingiverse. I've got a link in the description below. They're free to use. It's my gift to you. And when I was playing around with this, I stuck with simple sans serif typefaces. Now, sans serif are the ones that don't have little decorative corner bits on them. If you try a typeface like Times New Roman, which is fairly common, and you try to extrude that using the same technique that I've got to work here, it always fails. Now, I don't know why, but it's just something to do with the very narrow corners or the points on the letters, or the difficult geometry, or whatever it is. And my advice to you is stay away from any of the decorative typefaces. Just stick with sans serif, preferably fairly chunky, and it does work. Now, the other thing is that by creating individual letters, you have a little bit more creative freedom. So when you go to lay out your text, you can sort of stagger the letters, you can expand the kerning between the letters very easily, you can bunch them up if you really want to. And you can also print these in whatever size you want. So in your slicing software, you can individually scale X, Y, and Z, or you can uniformly scale and end up with multiple letters in several different type sizes. So I believe anyway that having individual letters means that you can print what you need, you can print them in whatever size you need, and at the end of the day, if you're making patterns, you throw it away when you're done anyway. So that was my thinking behind doing this, and so far it's worked for me. So let's go ahead now and get these on the backing and make our pattern. When you look at these letters, you'll notice that they don't precisely match up with the laser etching on the MDF. Now the reason for that is that the way I created the 3D models for these letters was to start with a regular typeface and then extrude that downwards, as you've already seen, and it gets bigger as it drops away from the actual sketch plane. So by using a bold typeface, it gave me approximately the correct kerning, that is the apparent space between each letter. But what I'm really after here is the baseline to be consistent all the way across that line of text, and also to get the kerning as close as I can. And I also wanted to make sure that I had everything centered on this perimeter here. Now to do this, what I've done is I've stuck a piece of blue tack at the end of a pencil, and that gives me a way of actually holding the letter and applying the glue to the back of it. The glue that I'm using here is a cyanoacrylate or a super glue, and we're just going to put a bit of that on the back of each letter and then bond these down in the correct place. Now this is not one of those really super quick setting super glues, so it gives me a bit of time to position everything. And it sort of helps not to have really shaky hands. Alright, so we're just going to press that down. Normally takes about 30 seconds for this to grip. So there's the first one done, so let's get a few more done. And I should mention also that all I've really done with these 3D prints is just to give them a light sanding all the way around the edge and scrape the edges just to make sure there's no stringing still attached. There was a little bit of that. So give them a bit of a clean up, but we're not needing to go completely overboard with this. We're going to use a process for painting which will help to smooth out all of the layer lines in the lettering. Okay, so I think you got the idea. Rather than bore you by doing each individual letter, we'll come back in a minute when we've got all of those stuck down, and then we'll do the perimeter. You can sort of see my problem there, so I think I'm going to do this in sections. So we'll get this end part done first, and we'll just let the glue wick underneath the edge while we hold it down. And then we can sort of be a bit more careful about how we position this. So let's do this end section first. I think we can just sort of flex that up. Alright, so we're just going to rinse and repeat, get the other half done, and then we're going to start cutting this out. Alright, so there it is. We're going to bandsaw this to shape now, clean up the edges, and then we'll get some paint on it. So on this outer edge I have to maintain a roughly 2.5–3 degree draft angle, and this will all be blended together later on, sanded smooth and filled. So I've got to get around and do all of these edges now. They're all the ones that can plane, so I'm going to have to do all these with the file. Right, it's going to need about 3 coats of a spray putty. You can buy this stuff at auto accessory stores. It's a high build, quick drying, easy to sand filler. It's heavy bodied, so it will build up very quickly and fill all of those layer lines in the 3D print. Okay, we're going to let that dry. We'll give it a light rub over with some seal wool. We need to be sure that we've filled any imperfections. So there's a bit of a gap here where the 2 3D prints joined. We need to make sure we've filled any of that laser engraving where it shows, and we want to get like a smooth, uniform finish on that. So over 2 days I've given this 4 coats of spray putty, front and back. It's filled in all of the blemishes quite well, so all we need to do now is prep this for our final coat. So steel wool works really well just to get in and around all of these little nooks and crannies. All we really want to do here is just sort of give it a bit of key and take off any dust that might have settled on the spray putty. You can also use a red Scotch-Brite. Okay, that's sort of taken all the high spots off that now, and it's ready for its finish coat. All I'm using here is an automotive acrylic paint. Doesn't matter what colour it is. All we're after here is just a smooth, hard, non-stick finish on this so that the sand or the green sand won't stick to this when we take it out of the mould. Now I've jumped ahead a bit here and I've actually moulded up the pattern, and that's not what we come here to see. It's actually whether we can get the pattern out of this mould cleanly without pulling away any of the sand. So let's get this apart and have a look. Alright, so far so good. Now I'm a bit worried this sand's too dry, but we'll check it out and see how it looks. So my sprue is coming down here, and I'm going to cut a runner right across through the sprue. Okay, it's about as crooked as a dog's hind leg. It doesn't matter. Oh, somebody else said it does matter. So I'll cut 2 gates. I'll tidy them up shortly. And just take a runner past the gates. Well, I got a feeling this is quite loose, so I'm not going to wrap it too much. Okay, so what we're hoping here is that when this comes out, it comes out clean and there'll be no sand trapped in any of those letters. Yeah, it's actually quite loose. Alright. So check that out. That's what you want to see. That looks beautifully clean in there. Now I'm going to put a bit of parting compound in this. Alright, so I'm going to tidy everything up here and we're going to pour this. I'll clean up these gates now, don't need to see that. And that part I'm really happy with, but I've got to be very, very careful to make sure there's no loose grains of sand, especially around this perimeter around here. So I'm going to do a bit of work, compressed air, blow all that out, make sure I've got nothing loose. Do a trial close, open it up, check it again, and then we're ready to pour. Join me with that. It's going to be fun. I'll overfill that a bit, but that's okay. Better to overfill it than underfill it. And if you're wondering what these little divots are on the top of the mould there, that's where I pushed this piece of wire through from the inside as a vent. So I've got one in each of the corners. Usually forget to do that. I remembered today. And we'll let this sit for a while and we'll come and check it. But let's hope for a first time good casting. Okay, let's see what we got here. Now, if this mould is only half full, I'll just destroy the evidence, delete the footage, and you'll never know. But anyway, let's see. Alright, that is looking good. Pity about my shocking gate and runner system, but it did the job. Okay, I'm liking that. The finish on the casting itself is not as good as I would like. A lot of people have commented and said that my greensand is too coarse. It's leaving a lot of texture in the casting itself. But this is going to get sanded off on the top here, dead flat. The background area will be powder coated, so a bit of texture there. Well, it won't be obvious. The only area that might be an issue is just here where the gate opened into the mould cavity. It's a bit grainy looking there. But I think I can cut down below that quite easily. Okay, I've cleaned all this up now. I've taken the riser slash feeder off the back here. That's where it was. And yes, it's a pain to get it off when you put it there, but I think it does a better job of saving this from any shrinkage if you put it directly on the back of the casting. On this side here, I've sandblasted this, and I know you're looking at it and you're looking at this texture here and you're saying, gee, that's bad. And yes, I agree with you. I'm not sure why it's so bad just there, but this was where the gate was. There were 2 gates, one up here, near the double O, and one down here. And it looks like it's washed a lot of loose sand in through that gate and it's all settled here. But that's not going to be a problem, or not so much of a problem when we do the next step. So instead of looking at that, I want you to focus on what's happened here in the center of each one of these letters, like the B, the A, and the R. And what I'm focusing on at the moment is the fact that that detail inside those is so good. And I think that's the reason why this 25-degree draft angle works so well. And when I was taking this pattern out of the mold, I didn't really have to do much. I wrapped a little bit, but I could tell it was loose already. It basically just fell out. So that was a good thing. And it means that you're not pulling any sand out of these little tiny details here. So that at least has worked well. But I know you're still looking at that, aren't you? Yeah, you are. But don't worry, we're going to fix that now. So our powder coat colour today is called Brunswick Green. It's one of those really nice heritage colours. Not that it really needs it, but I'll do the back as well. Okay, it's probably going to take about 20 minutes. Alright, it's all baked. We'll let that cool down. Ow, hot. Well, there's the finished result. Just off camera, I just broke the edges around the edge of the casting itself with some sandpaper. I've got some powder coated stainless steel countersunk head screws to match, and the Kookaburras are waiting, so let's go and get it up. Here we see the magnificent Kookaburra sitting high upon his perch, surveying his hunting ground below. He scans the surroundings, always on the lookout for a tasty meal of invertebrates like these worms, or sometimes a reptile like this fearsome paper snake. Okay, that's enough of that. Apologies to David Attenborough. It's Prezzo signing out. Thanks for watching. I'll catch you on the next video.